Hey everybody. So we are back and we're back and we're talking with Mr. Scott Koda Dudley. We're going to be talking about smart contracts. And if you don't know what a smart contract is, this is definitely the place to be. And even if you do know what a smart contract is, we want to invite you to participate in the conversation overall. Before we even get started, though, a question I'd love to ask everybody who's listening is if you are a programmer, an engineer of any sort, I'd love for you to raise your hand real quick or put an emoji up if you're a programmer. And curious to know then too, is anybody here writing smart contracts? Have you written a smart contract in the past? Have you looked into it? Love if you just write that in the comments and share that with you, or with us, I should say. And so with that, Scott, I'd love if you just introduce yourself real quick to everybody, and then we'll get right to it.
All right. Well, my name is Scott, but I frequently go by Koda. I have kind of had a career as an engineer, but back in the day, I sort of accidentally stumbled into engineering because I had a passion for trying to make video games. Part of that Super Nintendo generation in the 90s, and made my first video game in high school and kicked off a long career that's been kind of split between gaming, virtual communities, and actually kind of led into physical communities just a little bit. Let's see, most recently I worked in Seattle at a little shop that buys and sells Magic the Gathering trading cards, and was involved a bit in e-commerce there. And I left last March, on March 4th, which I think is kind of poetic, March 4th, to go full-time on a side project that I've been working on in the Ethereum space. I got started in Bitcoin, I want to say 2012, 2013. Got a good story there if you want me to share it. And then learned about Ethereum a few years later. It took me a little while to kind of figure out why Ethereum was important. But when the light bulb went off, I was like, oh, this is the next thing I got to spend all my time doing.
Yeah, well, I definitely want to hear more about Orbiter 8, and we'll talk about that a little bit later. But yeah, it sounds like that is a good place to start. In, how did you get into Ethereum, or how did you get into, call it, blockchain development?
Well, I ran into a post on Reddit that talked about this thing called Bitcoin. And in the context, I couldn't understand why people cared about it. So I went and looked into it. And at the same time, I just happened to be getting my master's degree in grad school. And I was taking a distributed systems class. My professor was absolutely amazing. He's very dedicated to the space. And he had told us, he said, if you find anything out there that you think is interesting, that's relevant to the coursework, let me know, and I'll introduce it at the end of the semester. So when I ran into Bitcoin, I was kind of understood the white paper, but I didn't really fully grok what I was digging into. So I introduced it to my professor. And rather than adding it on to the end of the coursework, he bumped out everything we were doing and he introduced it the very next day in class. He was just completely lit. So my inspiration was sort of set on fire by him.
That's
getting
great. Yeah. So the fact that, your professor is basically willing to abandon everything else for this, that told you, hey, this is something interesting.
Yes. And me, as I've been an engineer for a while. I have a computer science degree, but this guy, decentralized systems, that was his jam. So we got the blessing of having him describe the system from end to end in detail on the whiteboard. And it was inspiring. Took me a little while to understand Ethereum and the Ethereum virtual machine, but the minute I did, I was like, oh, you can build games on this.
Yeah, so let's actually talk about that. So from a programmer's perspective, or from a discovery perspective, where did you go, and where would someone go? So if I want to start writing smart contracts tomorrow, and I'm like, Scott, I need to learn this, what would you tell me to do?
One of my favorite resources that I recommend a lot, and this is a little bit gaming specific, and it's a little bit old now, is a tutorial called Crypto Zombies. And it came out not long after the CryptoKitties craze, I think everybody remembers, in 2017, nearly brought Ethereum down. And it takes you step by step through not only building the smart contracts on the back end, but also tying it into JavaScript on the front end for a client. By the time you make it through that tutorial, you can build a basic dApp.
Nice. And then what about because you said you like discovered the EVM or the Ethereum virtual machine and so forth. Can you explain that for folks that might not be familiar with what you mean when you say that?
Yeah. So somewhere along the way, we started developing virtual machines that were, in effect, a piece of software that simulates a hardware computer. This is, really popular for a lot of developers who want to spin up environments and don't want to have to use one machine per environment. So what Ethereum provides for is a globalized virtual machine. So the whole network is actually effectively a computer that you can run applications on. That it's a real basic concept, but a lot of times it's hard to grasp because you think about it, Bitcoin is just this distributed ledger. In this case, it's actually a full virtual machine that you can run applications against.
Gotcha. And when you're running these applications against, is that when you're thinking about dApps, or is that when you're thinking about smart contracts, or all of the above?
Well, smart contracts, yes. The smart contracts metaphor, one of the things that computer scientists love to do, they come up with metaphors for understanding how the technology works, right? Like in the case of managing our keys, we have these wallets, and we call them wallets because it's a metaphor for the wallets we put money in. Smart contracts are similar. It was sort of a financial institution metaphor so that people who are used to finance could have a clear idea. It's okay, contracts, law, systems that they can grok and get their heads around. But fundamentally, they're just programs. They're just programming language and programs. And in this case, in this instance, those programs all have standard APIs, ways that you interact with them, right? Like endpoints that you can talk to. And as an example, if you transfer an NFT, there's an endpoint you talk to that's called transfer, and you send data to it. Because of the way it's designed, any contract can talk to any other contract as well. So you have this interoperable system where contracts can engage with other contracts, which is a new paradigm that a lot of people aren't really that used to yet.
So that's super interesting, right? When you think about it, this new paradigm context. And I like the way that you broke that down in the sense that it's, using this metaphorical essential way. So let's get kind of right into it then. So what is a smart contract?
It's a small block of code that runs on the network when you actually execute it. Whenever you engage with a smart contract is the only time that it runs. A smart contract doesn't run by itself. It runs when somebody interacts with it with a transaction. And running it, at least in the context of Ethereum, means that you have to pay the network a certain fee to execute that code. And that fee ultimately gets distributed and disseminated to the miners that run the network. But when you actually run that contract, it doesn't just get run once. It gets run a multitude of times by nodes all across the network to ensure that what it produces and what gets recorded to the chain is accurate and consistent. So the result of that is that despite having an enormous amount of computational power on the network to crunch these contracts, the actual virtual machine itself is rather modest because these programs have to be run so many times. The constraints are relatively small. Storage is expensive. You've got to be careful iterating and using loops. And the way that they regulate all of this is the use of gas fees. And this is a little bit different on different networks, but Ethereum and a lot of networks like it just have a real consistent, you pay for gas, which is paid for in Ethereum. And as the network becomes more congested and more used, the cost goes up, supply and demand, such that you keep the use of the network down to a level that the network can sustain and keep up with.
Sorry, I was on mute. So in that context, then, does there needs to be an application layer, or how does someone decide to interact with this?
So there are a number of ways to interact with the contract. Like the most direct, perhaps maybe the nerdiest is to have your own node and have a console in that node and to be able to type those commands directly. You have to know the address of the contract. And you're going to want to know something called the ABI, which is basically where in that contract the actual endpoints are that you can talk to and what parameters you're allowed to send and what you can expect to get back. So if you have that information, you can use something as basic as a terminal and a Geth node to directly engage with the contracts. Most people don't do that because that's highly technical. So you need a UI, an interface of some kind that somebody can interact with. So One of those nodes is usually opened up with an RPC endpoint, which is sort of a Web 2 endpoint where you can interact with one of those single nodes. And then most Web 3 developers will build a JavaScript app, and that JavaScript app will connect to that endpoint through some form of wallet. And the most common paradigm is through MetaMask. So what you have is you have the end user in their web browser sending a transaction through MetaMask, which reaches out to an RPC endpoint that's connected to a node that's connected to the rest of the network. In other pieces of software, say if you want to use, I think Unity now has a plugin that lets you connect to a node. The wallet's sort of built into the software. So it still follows that same paradigm, only instead of being in a web browser, you're in some other piece of software. And this can be ported to really just about anything. You know, any programming language that has a Web3 interface built into it is something that can engage with the network. But to run applications on the network, you generally have to have some currency in a wallet so that you can pay for those transactions.
And so, you know, we're talking about, you know, NFTs for brands in this context today, right? And so how might a brand start to think about this? Is this something in your mind that they should consider getting knowledge in? Is this something that they should trust, call it an agency or a third party? Like, you know, because I know you have actually an experience working on the commerce side of things as well. And so when you think about like how often a brand might interact with this, on the, you know, on the computer side, on the programming side, you know, what are your thoughts there?
Well, we're sort of in that early stage, right? Where there's a higher risk, but there's also a higher reward. So if you're a brand that's out there doing something interesting, your opportunity for exposure is huge. You know, you're in a new space, in an interesting space. But there's also this higher risk where maybe if you go with a particular platform or a particular service, that service may or may not still be there in the long run. Your NFTs will, but those relationships are interesting. So it becomes sort of an individual question that each organization would need to think through. If they have a very big budget and the desire to go very deep, maybe building your own team makes sense. But otherwise, you're probably going to want to go through some form of agency or some form of service that's going to provide you with what you need. Understanding the new paradigms takes a certain amount of time, and then starting to derive innovations and ideas and building on that, it requires a pretty strong foundational knowledge to be able to innovate. So going with an agency that's sharp and understands the space is probably the best move for most brands at the moment.
Yeah, very cool. And so, you know, when we start to think about just kind of where smart contracts are today, so we're talking a lot about Ethereum, EVM. Talk to us about how, you know, because look, some people have concerns about gas costs or, you know, the cost of creating an NFT, for example. So walk us through how that happens. One of the things I always like to call a smart contract is an NFT factory, right? So, you know, how does that work? So if once you create the smart contract, what's happening next? How does this NFT factory work, for example?
Yeah, well, I think a little bit of precursor information that's good to understand is when we talk about NFTs, you know, a non-fungible token, in, as far as, you know, all lowercase letters, is a concept. It just means a token that's unique. In the space of what we're all working on, most of the time we're talking about what they call an ERC 721 token, which is a standard. And because it's a standard, it has a set of interfaces and an operability that everybody expects to be used. So because that standard exists, that's what allows anybody to create, say, a marketplace or something like that, and all of these NFTs to interop. But what's actually happening is out there you have a contract on the network, and that contract has storage space dedicated to it. And when you create an NFT, you're just creating a block of data that's of a certain format that gets saved to the chain. And if you say transfer ownership of it, what's happening is one line of data in there that is the address of the owner just gets written with a new address, and now ownership is transferred. So it's not really significantly different from operating with a database or something of that nature and saving it there. Only, you know, it's a giant database that everybody can use and has a certain amount of immutability and integrity that you can't get from a standard database.
Yeah, so let's walk through that one, kind of like even from an example that you sort of did right there, right? So that if you create the smart contract and then you're going to create the amount, you're going to start minting the NFTs, and essentially you have the NFT token IDs for the quantity that you're doing. Can you walk through what happens there and what that means from a technical perspective and how that looks?
Tell me a little bit more what you mean whenever you
I guess what I'm meaning is that, so for example, when you create the smart contract is what creates the NFT, correct?
Correct.
And then you essentially can determine how many NFTs you would want to create out of the same smart contract, right?
Yes.
And you would have, call it like a token ID for every NFT that's created. How does that work though? So for example, does someone create a smart contract and then say like run X amount of, code to make this many NFTs happen? And then from that point, do they perpetually do that? Or do you, I know sometimes people will create, call it like sub smart contracts, or essentially copy the smart contract and I muted myself. Walk us through the thinking of like, why would someone do it one way versus another?
Right. So the paradigm, the code, the way to build an NFT smart contract is thoroughly explored, and the source is already open source. So if you wanted to release your own contract, you can simply download the source now and publish it to the network, and you have your own, as you say, factory for NFTs. Those contracts that are out there have a way that they can inherit from each other and can interop. So it's possible that you have a contract that just inherits from another contract on the network, and you don't have to release that whole block of code every time. If you want to have unique functionality in your contract, if you want your NFT to do something that other NFTs don't do, for example, I recently worked on one that was a dice roller. So there's a method there that returns the roll of the dice. That's not going to be in your standard open source one. That's one that you have to add, but you really have to import all of the other functionality to get that. So to your question on the IDs, basically your NFTs are stored in what they call an array, and an array has an index. And when I say array, they have another concept in Ethereum that's called a mapping, which is similar, and there's not really any reason to get into the details of that. A mapping or an array, either one, has an index. So it's sort of like a variable with a number after it that identifies which one it is. It's sort of like a database record will sometimes have an index if you build your database, to best practices. That index is almost always going to be what they call a 256-bit integer. But when we see that 256 bits is huge, and even if you represented that in decimal, it's a very large number. I would try to say what it is, but I can't remember off the top of my head. It's an enormous number. So we generally represent it in hexadecimal, which contains not just 0 through 9, but a handful of letters because it's based in 16 instead of 10. So what you end up is with this string, an identifying string that's actually a number that's an index in that array. Some contracts will do this linearly, right? Like the first one will be 1 and then 2 and then 3 and then 4. You don't have to do that. In a mapping, you can pick any number that you want, and now that's your index for that particular object in the array. But generally, if you want to be able to iterate and do a lot of other things, you do them 1, 2, 3, 4, 5, 6. You're muted.
Sorry about that. I was got it. That makes sense. And that makes sense. And then so, let's talk about how, from a smart contract perspective, once the NFTs are minted, where are the NFTs that are minted? Are they in the smart contract still? Are you sending them to a wallet? What are the things that you're doing for those of us listening and learning?
Yeah, I feel like there's a couple of interesting pieces in here. So I'll start with, where does it technically live? The data of the NFT is stored on the blockchain in a block, and it is owned and operated by the contract that it was minted through. The contract itself can be owned by an owner who controls the contract, but not necessarily, probably. And then the NFT itself, it lives on the blockchain, but it has an identifier that relates its ownership to your wallet address. So you will see it, you'll perceive it in your wallet as yours, because on the blockchain, it is written that it belongs to you, but the data is there in the blockchain. But then part of where a lot of confusion comes in, especially with people who are sort of new to Web3, is what actually gets stored on the blockchain versus what isn't. And the NFT standard calls for a metadata URL baked into it. So whenever you want to get the actual, say if it's an image, it's going to come through something called metadata. And the most common practice is that the URL that comes from the contract takes you to somewhere outside of the network. That place outside of the network has a JSON file that contains that metadata. And inside that, it'll have a URL to say the image. But it could be to anything, right? Like, I believe Jack sold a link to one of his tweets, Jack Dorsey at Twitter. Anything that you can link to, which is a very, web concept, can be there. However, whenever you do this, where that piece is stored is really important, right? If you have that metadata sitting on a web server that's owned by a company that has it hosted on AWS and AWS goes down, you're not going to be able to access that anymore. The NFT still exists out there on the network and points to it and says that belongs to you. But if it's not there, you can't get to it. Alternatives to that are, say, something like IPFS, which is a big decentralized file store. And the hash that points to it is built out of the file itself in such a way that it can never be swapped out with something else. It has to be exactly that file. And if that file disappears and comes back, the hash will be the same. So long as it's out there on that network, you can access it. And this is a much better, more decentralized way of storing your NFT metadata. A third way that it can be done is you can actually encode the data itself that is part of the NFT, say the attributes, inside of the URL that's returned by doing what they call a data URL. This is rather limited because URLs can only be so long and you have to encode that data inside of it. So what you can do is perhaps send a very rudimentary image, whether it's an SVG or a pixel image that contains very little data. You can put it in that URL. In that case, it does all live on the blockchain. There are ways that you could perhaps add another method to your contract, to your NFT, that would return more data than that, but you can't count on services that consume NFTs like OpenSea or Rarible or whatnot to see those endpoints necessarily because they're not considered part of the open standard. I suspect that more methods for retrieving metadata will probably be added to a future standard of some kind, but I haven't dug into that real deep, and I don't know what momentum might be there in that case.
Muting and forgetting to unmute myself. So, so with that, can you touch on, go like one layer deeper in, call it, storing that information in AWS versus IPFS, right? So obviously, if you're doing the metadata or the file imagery in AWS, it's going to be more centralized. There is, that which has its pros and cons to it. If you're using IPFS, it's going to be, more decentralized, again, which has its pros and cons. Can you talk about that from a technical perspective, and then even give your insight to what you think from a, call it a socialized perspective as well?
Sure, I'll do my best anyway. So my reason for getting into this space to a degree is because I'm a decentralist. Despite having only discovered Bitcoin in 2013, I studied decentralized networks whenever I was doing my undergrad work in the 90s. And the problem then was that nobody really wanted to run a node for a decentralized network because there really wasn't an incentive to. But Bitcoin solved that by paying people to run nodes. And to do that, Bitcoin sort of had to be money. So, this decentralized scene that has exploded out of Bitcoin technology is very enthralling to me. The reason that I like decentralized technology is that it removes a sense of centralized authority. And you see this happening in a lot of cases, often good, some often bad, right? If you consider, news networks that are state-owned, they often control what information can get out. But people have used the Ethereum network to be able to release things that cannot be shut down, cannot be deleted. This, it circumvents the authority and allows these messages to get out. So this is, just an example of the value of a decentralized system. Something like AWS is centralized, and you have the owner of whatever account is on AWS that will be somewhat centralized. So say if you have a game, and you enjoy playing that game, and you've bought a lot of assets in that game, but the economy is not enough to sustain the company. The company has to shut down. If the company's running those servers and stops paying the server bills, everything shuts down. and it's over. Whatever you've invested in is gone. And this happens frequently. If you have a pure decentralized model and nodes are willing to host and maintain that data, then it's not necessarily going to get shut down. So if you take something like IPFS, which I don't have a thoroughly deep understanding of if we get too far into the details, but because it's a decentralized network, as long as the file that's out there is something that anybody on that network believes should be preserved, it's going to remain on that network. So if you have that community of gamers and the game is shut down, but the game client itself is available on that network, it's not going to get deleted. It's not going to get removed. Nobody can take it down out of spite. An authority can't go in there and remove it. And this has good effects and this has bad effects, right? If you just want to get a product out to the world, then centralized Web 2 architecture is far more mature, can scale better, has all the reasons in the world why you would want to use it. So why would you want to use something decentralized? It's going to be if you want your software to be basically unstoppable. You want it to be borderless. You want it to be censorship resistant. You want it to be immutable. If these are the things that you want to build, then this is the space you want to build it in. And a lot of times what you're going to see in the space is people are going to build things that maybe you find are offensive, right? Maybe they're going to build markets for things that you don't think there should be markets for, or products that shouldn't exist. And in this paradigm, that's going to happen. Those things are going to exist. But at the same time, people can get messages out that are critical for, supporting countries that are experiencing oppression, or, getting messages out that people otherwise can't hear, or getting money to people who are otherwise cut off and need that kind of support. So it's a different paradigm, and we have to build it so that it works better for people in the cases where it's good and not so much in the cases where it's bad. There's a huge amount of work to be done in that space. It's very exciting, it's very intimidating, and it's kind of a mind bender, really, when you stop and thinking about it.
Koda, this has been a fantastic conversation that I could probably ask you a whole half hour's worth more of questions, but unfortunately we do have to wrap it up. There has been one question in the audience, though, that I do want to ask you because it came up a couple times, and just to see if you're aware of it. How does one handle the function of whitelisting when it comes to putting with the smart contract, as well as from a NFT minting perspective?
I'm not deeply familiar with how a lot of people are doing it now, but I can tell you ways that I can conceptualize that it can be done. The first question is going to be, do you have your whitelist on chain or not on chain? If it's on chain, then you can directly build into your smart contract certain functionality based off of that whitelist, which is just going to be an array of those addresses that you have approved for whatever purpose. And in that case, everything needs to be coded into your contract. And I'm pretty sure that OpenZeppelin, and if people don't know, OpenZeppelin is an amazing resource for pulling down copies of contracts that are built for many use cases. They're very modular, can be remixed, and all of them have been heavily scrutinized by security professionals to be pretty tight. So you can pull down things that will give you, your whitelist functionality and whatnot, and you can build on top of that. Alternatively, if you just maintain your whitelist as something, you got a local spreadsheet or whatever, and you are the contract owner, you are the person who's going to be doing the minting, you can simply, whatever interface you're using to do the minting, refer to that whitelist and use it in that case.
Cool. Awesome. Scott, thank you so much. Really appreciate this. We went ahead and we're putting your contact info in the chat there. So if you see Ross just put, he's ZAS Koda. So make sure that you're following Scott Koda on Twitter. And then also, if you scroll up a little bit, you'll see Ross posted our YouTube channel. Make sure that you are subscribed to our YouTube channel. You can re-watch this interview, and you can watch everything that we've done so far today. But click on the YouTube link on the right, subscribe, so that way you can make sure that you get to keep learning. Scott, we'll talk to you soon. Thank you, everybody, and we'll get started with our next session in just a moment.